So, guys, recording has been started. So now let's start. Right. Let's just start. Right. So again, good evening, everyone, and welcome to this lecture. Right. So till now we have seen a lot of many things. So we have discussed, we have understood about Python. So we understood everything in detail. So till now, so if I have to explain what we have seen till now, then I will say that we have completed everything in Python. First, Python. Right. 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 So let's say I will just write it here. Right. So here I will write, we have covered till Python. Right. So we have covered Python. Right. And if you guys remember, I also discussed about a Python project with a GUI, right? Do you guys remember that Python project with GUI? That already we have discussed. Python project with GUI, right? We have already discussed this as well, right? So that was really fun that we discussed everything in the, that Python project. That was actually very nice project, if you guys remember, right? That was really good project at I feel so, at least I feel so that that was a really good project, right? Right. After that project, right? So if you guys have seen, right, if you guys have seen things, right, if you guys have seen that, right, I have again posted few more things, some 10 projects, 10 mini projects with solution as well. Have you guys seen that? Yes or no? Have you guys seen that? So I have posted 10 projects, right? So I had promised you two, I have posted 10. Now it depends on you, right? How to utilize that, right? How to work with it. And you can now again, you can again have work on those projects. Actually those are mini projects and mini project ideas, and you can make a full-fledged big project like that I have done with the net banking app. First of all, answer me, how many of you have seen that project? Yes or no? Anyone saw that? Quickly, yes or no? Yes or no? Anyone saw that? Quickly. Right. Anyone saw that? Right. 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 Yes or no, guys? Have you saw that? Yes or no? I just want to see. Right, right, right. Okay, so you guys have saw that mostly, right? I'm not able to see enough of yes, right, right. Okay, guys, don't request for admin. I am seeing many people are accepting, requesting for admin. Please don't send the admin request, right, right. So just join. Arey yaar. Many of you are sending the admin request. Please stop that. Right. Just join as a member, and at a later stage we will be seeing that. Right. If you want to share the screen at a later stage, right? But let's say 10 projects we had put. So anyone has seen that or not? Just yes or no. I want to hear yes or no quickly. Yes or no from anyone. Rishabh, please don't share your screen. Please unmute yourself. Right.
I'm not able to see the chat option actually. I want to write something, but I'm not able to see that.
Okay. Are you able to see the chat option now?
Yes, yes, yes. Okay, thank you.
Okay, just uh, okay, now good, very good, very good. Sorry guys, sorry. I don't know what it happened. Very good. So let's start, guys. Let's start. Maybe I will just start it again. So mhm. Okay, this as usual. Good evening, everyone. So let's start, and then so we have seen Python, everything about Python till now. Then we have also seen a Python project with GUI, and I have posted 10 projects, right? 10 mini projects. Many of you guys are asking where are those 10 mini projects. So what I can show you. So go to here, then go to career craft, right? Continue with email, whatever way you want to do. You can just have this, go to the library, right? Here you have some course, go to this course, and now here in Python programming, if you just go down, then you will find Python 10 mini projects, Python mini projects authentication system. This is just a generic authentication system. You don't need to worry about that. I was planning for each of this 10 mini project, but anyway, you guys can use it. These are the Python 10 mini project and Python mini project of authentication system. Now, are you guys able to see this? Everyone, right? Everyone is able to see this. So now, guys, it depends on you how to utilize this, right? My job was to give you project. My job was to give you a live demonstration. I have done that. Now you guys have to actually work hard on the Python part, right? Anyway, we have also created a WhatsApp group, and if needed, right, you can ask any questions on the WhatsApp group. So let's start. So we are going to study, we are going to start with NumPy, and we are also going to see some interview questions in the last. So we are going to start with NumPy, right? We are going to start with NumPy. Today our plan will be to complete NumPy, and believe me, I have seen YouTube classes of all the big YouTubers. I don't have any hesitation to say this, that I have seen all the YouTube lectures of all the tutor out there on YouTube or paid courses, everything. Be it any Indian tutor or be it any tutor apart from India abroad, somewhere, anywhere, I have seen. So, what I am going to do, whatever knowledge I have and whatever I have learned from other tutors, so I have compiled everything. And for data toolkit, we are going to see everything in detail. This is going to be a lot of fun. So data toolkit, what is data toolkit? I will come to this. So data toolkit comprise of the libraries in Python that is useful for data science. Libraries in Python that is very useful for data science. So for example, NumPy, pandas, then we have matplotlib, then we have cborn, right? So we are going to see all of this one by one, cborn and let's say plotly. So we are going to see everything in detail, right? And bouquet as well, right? Now, now, the question is very simple. We are going to learn these things, everything in detail, but how it is different from, how it is going to be different from, right, other people. So this is going to be a lot of difference. There will be a lot of difference because I am going to complete everything holistically first. Second, with respect to industry, what is actually going on, right? So NumPy is fine. NumPy you will not find that much of application, but there will be some application. But pandas very important, specifically 2 3 functions like merge, join, concatenation, very important for data analysis, right? And as promised, at the end of the data toolkit, again you will be having 2 projects, right? But this time again I will increase this 2 to 10 projects or 5 projects. I will see at that point of time how many bandwidth I have, and I will increase that number of projects. So you guys no need to worry about that how much practice you are going to have and how much practice you are not going to have, right? Further in EDA, sure short you are going to have 10 projects, right? 10 data sets I am going to solve, right? So this EDA will also be related to this data toolkit. So you don't need to worry about anything, right? Right. Before that, one more thing I am thinking, since Python is already over, we have taken almost 2.5 months to complete Python. Generally, right? If I have to think in terms of monetary benefit, then Python has to be covered in just 1.5 month, right? But that's okay for me because this is my class and I can delay everything. I can have a lot of quality content. I can expand anything. Like, so if you remember, named spaces we studied for 3 hours, but if you see on YouTube, you will find that namespaces is taught in just 15 to 20 minutes. But the main idea is again, we are going to see it in detail. My target is to complete data toolkit in January, right? 3 to 4 weeks, this should be completed so that in Fab we can start with SQL. Then in March, we can start with statistics and EDA, and April, machine learning, deep learning, NLP. That will be the continuous thing with projects, right? Obviously. So that would be my idea, so that by June, we are in a very comfortable position. April, May, June, machine learning, deep learning, NLP, we are in a very comfortable position that you guys can start applying for job and something like that. So this is the plan as of now, moving forward for the next 6 months, right? Rest WhatsApp group is already created. Also, if you guys need personal suggestions, do let me know. If you guys have, in that WhatsApp group, since you guys have, you are a part of career craft, so I am approachable for anyone in this particular, group, or in this particular class, whoever he is or she is, right? So let's start with NumPy, guys. So we'll start with NumPy, right? We'll start with NumPy. So let's start. Our target is to complete the NumPy. First of all, let me start stating with one very simple thing, that why are we moving to data toolkit? Why are we moving to data toolkit? First, what is data toolkit? Why are we moving to data toolkit? That is completely fine, right? But before that, what is data toolkit, right? That we have to understand. What is data toolkit? Anyone has any idea what is data toolkit? Quickly, what is data toolkit, right? Anyone has any idea what is data toolkit? Powerful tool, Rajkumar says powerful tool. Very good, Rajkumar, right? So if I have to say that what is a data toolkit, it is a set of tools which is going to be very helpful in data manipulation. That's it. That's it. Right. Right. Tools useful in data manipulation. Manipulation. But again, the question is why? Why do we need to have the knowledge of data toolkit? Right. And here comes an important concept, that is Monjolika. So Monjolika will answer this, right? Yes or no? Everyone agrees to this, right? Yes or no? Let me check how many of you agrees with this. Okay, Rajkumar says yes. Okay, nice, fine. So here I am going to search one thing, that is crisp DM framework, right? What is this crisp DM framework, right? This crisp DM framework is very important, and for this I have this particular image that I will copy paste here in this notepad. So I will just copy this. So this crisp DM framework is very important to understand, right? So what is this crisp DM framework? Suppose that, right, Monjolika's child is born. So let's say a child is born here. So when a child is born, there are different stages, right, of this child. First stage is cry baby, will keep crying. Second stage will be walking baby, right? Third stage will be teen, where he or she will start having crushes on other teen. And then comes the adolescent stage, where he starts or she starts dreaming of dating someone. And then finally becomes adult, where he or she actually dates someone. And then finally becomes matured adult, where he or she gets married, then becomes old, and then becomes die. Don't become anything, but let's say die. These are the stages of a human life. Very simple. Similarly, whenever you work with data, there are some stages. First, know the data or read the data. First ingest the data. Right. Second, you have to start understanding the data. So data understanding. Then you have data preparation. Then you have modeling, that is machine learning modeling. And then finally, evaluation and deployment that we are going to look at a later stage. You don't need to worry about this. But the idea is to understand or to know how the data is ingested. Ingestion means read the data. As of now, just understand this, read the data. Data ingestion, data understanding, data preparation. So this is something. How you will do? You will use some set of tools to do this, and this set of tool is called as data toolkit. So why data toolkit? In order to have some data manipulation technique, and you will be having some inbuilt functions in this tool which will help you to analyze the data. Is it clear? Quickly, is it clear? Everyone? So far, so good? Right. Now, enough of Gyan, enough of Gyan, enough of Gyan. A lot of Gyan has been, uh, given here. Now, let's move ahead, right? Let's move ahead in understanding what is NumPy now. So, data toolkit you understood. Now, useful to understand the data, to understand the data. What are the part of data toolkit? Part of data toolkit is numpy, pandas, matplotlib, it cbon, etc. Just complete it, you know, guys. Okay, I will write it because many of you might not know it. So matplotlib, cbon, plotly, and so on, right? Very good. Now we are going to start with NumPy. Now the question is, what is NumPy? What is NumPy? You guys have to answer me. What is NumPy? NumPy. What is NumPy? Right. Very good, Sazil. Very good, Sada. Very good, Rajkumar. Very good. Very good. So if I have to write do Sandhi Viched, so NumPy is something like this. New pi. So this is numpy. Nu plus mpy. Numpy. So nu stands for numerical. Pi stands for Python. Actually, am should be this side. So numerical Python. Right. Now, again, what is this numerical Python? Right. So for this, I will take the help of NumPy official documentation. NumPy official documentation. Now let's see what is this. Right. So if you see here NumPy documentation, you will get something. Oh my God, this is a wrong documentation or what? Let's see it. Okay, so here is NumPy. Right. So I will simply copy paste it. What is a NumPy? So I will talk about this in detail. So you don't need to worry about this. But here we have NumPy. Right. NumPy. So NumPy is a fundamental package for scientific computing in Python. It is a Python library that provides a multidimensional array object, blah, 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 blah. Nothing of my use case. Don't worry about that. This definition you don't need to remember. But the statement that I am going to write is at the core of NumPy is and the array object. That's it. This is the most important statement. Rest is just a bookish knowledge. That's it. But again, we'll come to this one by one. So first of all, why NumPy is called as numerical Python? Because NumPy has all the function associated with any numerical calculation. That's why it is called as numerical Python. Why it is called as scientific computing? Scientific computing because you can make or you can do any mathematical function from basics to advanced level using Python. Right. First thing. So NumPy is a fundamental package for scientific computing in Python. Very good. It is a Python library that provides a multidimensional array. Don't worry about this array. I will come to this again. Right? Right. But here, if you see logical operator, you can do logical, if you remember, and or. If you guys remember, logical and or, you can do anything like this operation using NumPy. Shape manipulation, I will discuss about this shape manipulation in a very easy way in the coming lectures, not coming lectures, in the lectures ahead. You can do sorting, how to sort some array, you can do that as well. Selecting, you can do indexing and slicing. Input output, discrete Fourier transform, I wanted to come to this. What is Fourier transform? Do you know this about? So in your engineering first year, you might have studied about this Fourier transform and Laplace transform, right? So these two transforms are scientific calculation or computation highly used in signal processing, right? Even if you don't know, you have to just Google it out, a formula of Fourier transform. Just do it, Fourier transform. So see here, if you just Google it out, these are the Fourier transform formula. See here, these two, see, these are the Fourier transform. But obviously you don't need to remember this, you will not be using this. Then why I am showing you this? I am showing you for a simple reason, to know, to make sure that you know the importance of NumPy, that NumPy is not only useful for some basic operations but also for advanced operations. Laplace transform, Fourier transform, basic linear algebra, statistical operations, random simulations, everywhere NumPy is used. And we are going to see the implementation. I will show you the implementation, but that's the understanding. That's the understanding. Clear? Yes or no? Yes or no? Right? Right. So far, so good. Anyone has any question? Ada, do you have any question? Are you understanding everything? Yes or no? Very good. Very good. Very good. So I guess there is no any question. Then we are going to move forward. I have written one thing, at the core of NumPy is ND array object. Now, what is the meaning of this? So, first thing, what is NumPy? Till now, what we have seen, NumPy. NumPy is what? Used for scientific computing. But to compute it, for doing any scientific computing, you need some data type? Yes or no? If I say do addition, on what thing you will do addition? You will do addition on two numbers, 2 plus 3. These are integers. Right, right. Similarly, if I am saying using NumPy, you will be going to do scientific computation. On what thing you will do the scientific computation? You need to have some data type. Right. And that's where comes the concept of array. Array. This is array. But now the question is, if we have integer, float, right, complex, list, right, tuple, dictionary, right, in Python, then why we have array? Why we have array? That's the question. Why do we have an array? Right? Is it that Monjolika told to have the array? Is it the reason? Right. Why array? Right. So first of all, now let's move ahead. I will write something here. NumPy is an ND array object. So first of all, array. Array is the basic data structure of NumPy. But now the question is, if we have all the data structure on the earth, then on the earth, no, don't write in Python, then why array? Right, right. Then why array? Right. Why array? You have to answer this. Right, right. Why array? Right. Aditya, you have to answer it. So Aditya is I don't know how many of you guys know, but Aditya is the head of management team of career craft. Sajil is one of the intern here, right, who is uh, also a student of this class. So both of them I got through different batches, right? But they are helping me a lot in smooth functioning of the classes. So thanks, Aditya. Are you there, Aditya, or is it that you know you have dropped? I don't know. Are you there, Aditya? Right. Okay. I don't. I think that Aditya is not responding. But anyway, okay. Aditya is saying I think I am different, Aditya. Okay, Aditya. Okay. So that Aditya is different. Okay. But Sajil is same. Sajil is only one. He is unique. But anyway. So now why array? That's the question. That's the question. Right. 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 So let's try to understand this in detail. Why, why array? Right? Why array? But before that, do you guys remember? So I'll just write it one way: numpy array, numpy array, numpy array versus right Python data structures. But before that, do you guys remember one thing? Tuples said something like that. But before that, do you guys remember one thing I have discussed earlier as well? That how, if you define a list, how the element is stored? Do you guys remember that? Yes or no? Do you guys remember that? Right, 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 right. Right. Very good, Sada. Only Sada was able to answer it correctly. So if you guys remember, the moment you write 1, 2, 3, 4, this is not stored in the memory block like this. 1, 2, 3, 4. No, it is actually stored something like this. 1, 2, 3, 4. And then there will be a address which will actually, so let's say address is 221, it will store the address 221, 228, 229, 330. Do you guys remember this? I had discussed this. Yes or no? Everyone? I had already discussed this, right? Very good, very good. So NumPy array versus Python data structure, list, tuple, sets, whatever it is. So list, list stores the data, list stores the data in the referential way, right? Right. Or with reference address, with reference address, with reference address, right? This is the understanding. Is it? Right? Everyone remembers this. This should not be any problem with it. Very good. But now, another question. Don't you think this will make list slow? Make list slow? Right? Right. This will make list slow. Don't you think? Yes or no? Very simple analogy, guys. If you want to reach to London, right, right, which will be super fast if you go directly to London, or first if you go to Birmingham, right, then you go to some state in Austria, some city in Austria, and then go to London, right? This will be slow, this will be very fast, simple. There should not be any if and buts, right, right, right. Now, this is the first demerit, right? That lists are slow. And in general as well, right? And in general as well, in general as well, Python is a programming language which is very, very slow. Do you guys know which is the fastest programming language? Everyone. Which is the fastest programming language? Everyone has to answer this. Very good. Very good. Right. Right. Very good. Right. So now, now, Python is not so fast. C++ are the fastest programming language. Right. Python is slow. Now the question is, till 2008 2009, you will be surprised to know that all the data science till 2008 and 9, all the data science was done in R and MATLAB. I don't know how many of you know. MATLAB is again a tool that was in my course actually, right? I have used MATLAB, and R is another programming language, right? Right, right. Rishabh says why Python is slow. This design, it has been designed in such a way that it is slow. One example, see here, reference address. That's why it is slow. Right. In C, there is no any referential way of addressing thing. No, interpreter or compiler doesn't make any difference. Right. It will not make any difference. That amount of difference. See, because what will happen at the end of the day, compilers are fast. That is 100% sure. Right. Interpreter are a little bit slow. But if you dive deep into Python, you will so be surprised to know that Python is an interpreted compiled programming language. Right, 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 right. So it will not make that much of difference. Obviously, compiled programming language is way faster than interpreted. But at the end of the day, in interpreted, so see what is the difference between interpreted and compiler, right? Interpreted and compiled programming language. What is the difference between both of them? Right, right, right. Anyone else? Right, right. So here compiled, here it will be in one go. So it will be in one go, right? Interpreted line wise line. That's the first main difference and nothing else, right? Right, that we have to understand, right? And now if you see, if you have studied modules and packages, you might saw PyCache. Do you remember that while I was executing modules and packages, this PyCache was created? What was this PyCache? What was this PyCache? Right, this PyCache was nothing but the compiled binary code of that script. Now answer me. So everyone says line by line, but that was the binary script of a compiled, what to say, Python script, right? Right. So idea is very simple. This will not make that much difference. By design, right? C++ is little bit faster, right? Right. Very fast, not C++ little faster. It is very, very faster, right? Rishabh says in C++ there are pointers now that stores reference address. That pointers are fast. I understand where are you coming from. I understood that what you are meant to ask. That pointers are actually very fast, right? Right. There are other ways also. There are other reasons as well. I will come to that. But as of now, right, this is the first thing by design, right? Due to right design, the Python is little slow as compared to C++. Right. Can ML be done in C++? Few people have done it, tried doing it, but not worth it because you cannot develop everything from scratch. Right. Now, coming to the main agenda now. So we have understood that fine, that here it is slow, right, right, right. NumPy, sorry, Python is slow. I will talk about this, how, what are the other reasons that Python is slow. So you don't need to worry about that. I will come to that reason. I will show you the examples. Don't worry about that. So what to do next? Then some researchers can come into the picture. Some researchers comes into the picture, right? Some scientist says that, okay, right, computer scientist says that why not develop a data structure, develop a data structure, develop a data structure. Why not develop a data structure in C and use in Python, and use in Python? And that's how the NumPy array comes into the picture. Comes into the picture. Why everything is slow? I will come back again. But as of now, this is the first thing. Is it clear? Why the NumPy array was right necessary here? Right, right. Quickly, yes or no? Right. Praveen says C++ is compiled into directly machine code. Yes, that is also one thing. But Python can also be directly compiled into the machine code. What is the problem there? Right. Right. So far, so good, guys. Till here, anyone has any questions? Right. What is the necessity of NumPy? Everyone got this picture? Quickly. Right, right, right. Is it clear, everyone? Yes or no? Till now? Right, 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 right. Very good. Now, coming to the other pointers. Why, right? Why this particular NumPy is slow as compared to other data structure. So NumPy versus Python list. So now this is the topic that we are going to discuss for next 20 30 minutes, so that you guys can have a bigger picture. Because you know, someone might ask you why NumPy is faster than Python, or NumPy array is uh, faster, right? So we are going to see this in detail, one by one. Right. Now let's try to understand this one by one, everything in detail. First point. So we'll start with first point so that it is very, very clear. First point. First point. Right. Right. Whenever you create a list, how list is created, guys? You have to answer me. How a list is created. Right. How a list is created. Do you guys remember? Right. No, A is equals to 1, 2, 3, 4 is fine. How list is created in terms of memory? In memory, how it is created? Do you guys remember that? Right. So list actually actually grow grow actually list can grow. Let's say list can grow on grow dynamically. Let's say dynamically. This is the first thing. List can grow dynamically. Do you guys remember that? Right. What happens? So whenever you have made a list, so let's say you have made a list, right? For example, you have made a list, right? You have made a list, right? Some memory block has been allocated, but the moment you do dot append, right? This particular list will be extended. Again, it will be extended. Again, it will be extended. And the moment this memory is exhausted, right, 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 it will again try to increase the memory. This is the understanding of the list. Yes or no? We already had discussed this, that list can grow dynamically. But now, right, right, NumPy array has fixed size in creation. So NumPy array has fixed size in creation. But NumPy array has fixed size in creation. This is the first thing, right? This is the first thing. Is it clear? Right. Is it clear? Yes or no? Right, 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 right. Sir, it's slow but very useful in this manner. What is slow? What is very useful? Right, right. Okay, list is slow but useful in this manner. No, I will show you the demerit of this. Don't worry about that. I will come slowly. Don't worry. Right. So is it clear? List can grow dynamically, but NumPy array has fixed size in creation. Fixed size during creation. Very simple. Actually, I will write at creation. Now, second point. Right, 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 right. NumPy supports many advanced scientific calculation. but list doesn't support. This is the second point. Right, right, right. So list, what are the operations that you saw on the list? Right, you saw very simple operations. What are the operations? Append, add, concatenate, extend. That's it. Yes or no? But not any scientific operations. Right, that is possible in list. And these calculations are executed in a very optimized way. This is the second point. Right, 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 right. It third point. It also supports Python inbuilt data structure. Inbuilt data structure. Data structure. So it also combines NumPy array with Python's inbuilt data structure like list, tuples, sets, and dictionary. And that is what NumPy becomes more and more powerful. And the last, it takes it takes it takes less computation time, and it takes less computation time and memory. I will prove everything. You don't need to worry about this. I will prove everything. But this is the comparison between NumPy versus Python list. Right. Now, this will be very much clear. Now, seeing the above pointers, it must be clear that NumPy array is faster. NumPy array is faster. But now the question is, right, as someone had asked, right, why Python as a whole is slow? Why Python is slow? Right. So first of all, we understood why NumPy array, that particular data structure, right, is faster. We have got these pointers, that above pointers makes the NumPy array faster. But why Python is slow? Right. See, Python is slow by design, first thing. But what is that thing in design that makes it very slow? Right. Right. So do you remember one thing? Dynamic typing. Do you guys remember this dynamic typing? Everyone? Do you remember this dynamic typing? Yes or no? Right. 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 What was the dynamic typing? Right. 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 Everyone? Right. 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 Do you guys remember dynamic typings quickly? Right. How many of you remember that? Sada says yes. Changing the data type after declaring? Right. Rajkumar says this correctly. No need to declare the data type. So you don't need to write something like this. Int, float, like this. Int A. As you do in C or C++. You do this in C. In C and C++. Right. Right. You don't need to do it in Python. You don't need to do in Python. Now guys, see, whenever I say that Python is slow by design, always think in terms that why Python can be slow. Because Python is very easy to use. But why it is easy to use? Because Python has been made easy to be useful or to be used, right? Whenever someone use, Python has been designed in such a way that is easy to use. Now think it, int A, if you start writing this in Python, obviously it is going to be a problematic thing, right? Obviously this will make Python more complex. So Python told that we will support dynamic typing. Dynamic typing says you don't need to declare, no need to, you need not, you don't need to declare the data types. And now Now you already know Python is an interpreted programming language, right? Compiled interpreted programming language. But let's say you don't need to declare the data types, then what will happen? Right? It means if you don't need to declare the data types, then Python on the runtime needs to check the data type, or needs to verify, or needs to know, check or know the data type. And that's what it makes the slow execution, right? Slow execution. This is something you can understand. This is the first point. Second, I already had talked about global interpreter lock, right? GIL. Python says I will restrict multi-threading. That's it. Restricts multi-threading. Python never supports multi-threading, right? Restricts multi-threading. It means not true multi-threading. True multi-threading restricts true multi-threading. So what is the meaning of restricts true multi-threading? It simply means at one point of time only one thread works. I had already discussed this in multi-threading and multiprocessing. So it actually limits the utilization of multiple CPUs, right? Right. These are two main reasons you can consider that Python, which makes the Python slow. But our point of discussion is not this. Our point of discussion is NumPy array. So far so good, guys. Everyone is clear till here. Quickly, yes or no? Quickly. Very good, Tanya. Who had asked why Python is slow? I guess Rishabh. Is it clear now, Rishabh? Quickly. Everyone, yes or no? Quickly, guys, everyone, yes or no? Right. Saurabh, I have already uploaded a regex notebook. You can go ahead and see that. Today in the afternoon, I have uploaded the regex notebook, right? Where you can see, right, right, uh, all the uh, regex related functions. Okay. So can we use NumPy in C also? See, C has a different library, not exactly NumPy you can use there, right? Not by the name of NumPy, because NumPy is what? A array. That's it. If I have to say what does NumPy represents, I will say an array. What is an array? A data structure which has some characteristics, which is something here. That's it. Okay. Now, guys, should we move ahead to prove all of these points? So I will slowly prove these all points. But before that, right, what is a NumPy? NumPy is a library. So now I will just write NumPy, numerical Python, numerical Python, numerical Python. And this is a library. What is a library? Library which consists of multiple modules and packages. Right, right, right. Library means multiple modules and packages. This is the understanding. Now, when was NumPy developed? NumPy was developed in 2005, right? Got to the peak in 2011-12. This was developed by Travis, if I'm not wrong, Travis Oliphant. Anyone just Google it out. But it was developed by Travis Oliphant. Okay, right? It was developed by Travis Oliphant. Now, what is the version of NumPy? Just you can just write np dot underscore underscore version underscore underscore like this. So you will, okay, I haven't imported NumPy. See, by default, my mind is set that NumPy has been imported. So import NumPy as np. And if you want to see the NumPy version, so this is, I guess, the most current NumPy version that I am having. And if you just print the official documentation, so np dot underscore underscore doc underscore underscore, you will see this particular thing, that NumPy Details are this. So provides an array object of arbitrary homogeneous item, fast mathematical operation over arrays, linear algebra, Fourier transform, and random number generation. These are actually the things that is very, very beneficial in NumPy. Clear? Yes or no? So far, so good. Right, very good. So now, what is NumPy? Right, so here you have understood that is a library that stores NumPy stores data in an array. First thing. Second thing, what is an array? An array is a container to store the data of same data type. I will come to these things, I will discuss everything, right? And the third thing, very, very important, that computation with NumPy array is fast. NumPy array is fast, right? Right. Why it is? I will come to this. And it is very useful in mathematical computation. Now, guys, let's come to the main thing. We have discussed the theory part in a very good way. Not a problem. Right. But now I am going to prove everything. I am going to prove everything. Right. Right. So first of all, I will show you how to make a list and array, because I will come to other part as well. But let's say L is equals to, I am just writing 1, 2, 3, 4, 5. L is equals to 1, 2, 3, 4, 5. So now I will write np.array. This is the way you make a list into an array. So now if you execute it, see here, this is an array. You can store this in any variable as well. A is equals to this. And if you see the type of A, you will find this. It is NumPy and dimensional array. Very simple. Everyone has done till here. This is the very basics how to convert a list into array. Right? Everyone, yes or no? Let me know till here. Right? Right? Everyone? Right? 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 Now, you guys now know. Right? Right? You guys know. Right? 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 That how to make an array, right? How to make an array out of list. Very simple, right? Right, 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 right. Now I will do one thing, right? What I'm going to do, right. First thing is that I will make an array. I will make a very big array, right, right, right. I will make a very big array, right, 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 right. So I will just write something like this. See it carefully. So what I'm going to do, right? NP dot, see here, A range. What is this A range? You don't need to worry about this. You don't need to worry about this. NP dot A range, right? And I will put something like this, right? Some number, right? I want an array of this much of memory, right? And then A is equals to this. See it carefully. I'm not going to do anything. I'm just writing something like this. Now, if you see, this is a NumPy array with these number of elements. Clear? Yes or no? See what I'm going to do. I will just explain you everything in detail, but is it clear? Right, right, right. What I have done? I have just made a NumPy array. Right, 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 right. Now, this is going to be a very fun thing, right? Now, I am going to make a list, right? So, how to make a list? Similar to this arange, right? We have another function in list called range. Do you guys remember this? Right? Range. So here I will just write this range function. So here I will write range function. Not a problem. And you know that this range is nothing but a type of generator. So you have to write list here, or I just set like a list. So if you write like a list something, then it will give you some number. These are the numbers. So let's say I will just store this in B. So what is B here now? B is a list, something like this. So I will just show you type of B is this, right? Not a problem. Now guys, I will show you one thing. This is going to be fun. Now here I am going to import a module called sys. Already you know what is a sys. And in this sys, I am going to use sys.getSize. Sys.getSize, right? Of sys.getSize of A. So you see here, this is the memory space. Very good. And now using same thing, sys.getSize of B. Oh my god. There is some problem, guys, right? Don't you think that this memory space, which was an array, is this much? Sorry, this much, and which was a list, it is this much. Which is bigger? What is the thing that happened here? Right, right. And the most important thing, how much it is bigger? How much it is bigger? Can I say that this is twice of that of NumPy array? Right. So list memory is twice that of array. First thing, is it clear? Yes or no? Right, 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 right. Now, this is the first thing. Now, the reason is why less memory. Now, you have to answer this, guys. Why less memory? This is the question now. I had told you I will come with every specific point and I will discuss this in detail. Now, answer me, guys. Why? Why the list memory space is twice that of an array? Answer me. Vedic says array compressed data, dynamic memory address. Very good, Sada. Right. Very simple answer. Right. Array, unlike list, has contiguous. Contiguous means continuous memory allocation. Is this point clear? Right? Is this point clear? Yes or no? Right? Right? NumPy memory uses lesser than list. Right? Now, moving ahead. Now the question is, can we more reduce? Can we reduce more? Can we reduce the list memory more? Sorry, reduce the array memory more? That's now the question. Can we reduce the array memory more? Now that's the question. Can we do so, guys? Right? Can we do so? Right? Jyoti says yes. How? How you can do, Jyoti? Rajkumar says no. How? Why cannot we do, Rajkumar? What is your logic? Right? You says no. But let's see it, guys. Let's see it. np.arange, this is something like this. Now what I'm going to do, dtype is equals to dtype dtype is equals to np.int 32. Let's say I'm doing this. And again, sys dot get size of, let's say, A. Let's try to do this. Get size of A. Right, right, right. Now see, this is the memory that we already have seen here. Very good. Now Now I will copy this in another block so that you guys not get confused as a note. This is the understanding. Now what if I do 16? See, isn't it memory reduced? Right, right. Again, can I do 8? I guess 8 is also possible. I'm not sure. Let's see it. 8 is also possible. Int 8. See here. Oh my god. Very good. This 1 by 8. See here. Can we reduce it more? Right. Instead of int 8, I don't think 4 should be an option. No, 4 will not be option. Very good. But at least we have reduced the memory using NumPy array. See, right? U int 8. So let me try do that as well. U int 8. No, it is the same thing. It is the same memory. It is universal and it doesn't make a difference. But this is the understanding. Is it clear, everyone? Yes or no? Quickly. So you can also reduce the memory using NumPy array. Now, obviously, if NumPy array is low, memory is low, it will be faster. I will again come to another important thing that we have to discuss. Right? NumPy array is faster. How? Let's see it. NumPy array, NumPy array is faster. Actually, I have shown this earlier, right? In I guess master class, some sort of master class. I don't remember this exactly, but already we have seen this earlier, right? So what I am going to do it. So let's say we have, see it carefully. This is going to be fun, right? Right. This is going to be fun, right? Right. Now, what I am going to do? Let me think what I can do it to show you that NumPy array is faster. Oh, Okay, so let me try it, guys. Let me see this. Right, right. So what I'm going to do, right, right. Here, I am going to do one thing, very easy thing I'm going to do. So let's say I am going to have one small piece of code, right? So what I'm going to do, right? See it carefully, right? For, for, okay, leave it this code, I guess. Okay, let me do one thing. I will make a list, right? List. So list of what? So list of, let's say, range, let's say some random. I don't know what is this, but let me see a. Fine. This is your list a. I will now just copy this, right? Range of this, right? And now I'm going to copy this and just add b is equals to this. And now here also I'm going to put this number, equal amount of numbers I want. So let's say this is also b. So we have a and b. So if you see length of a, right, length of a and length of b, it will be equal, right? See, let's see, this is the equal. So far so good. That's not to be a problematic thing. Now what I am going to do, right, these are a and b. Now what I am going to do, I can just multiply the number one by one, or add number one by one, or subtract the number one by one, whatever you want to do, and store that in another list. So let's say c is equals to, this is another list. Very good. And then I will store import, right? Right, not import. I will come to this import again. So here I'm going to import, but anyway, c is there. Now for I in range, for I in range, right, right, for I in range, length of a or b, whatever you want to take. So length of b, both are of same length. Now what I'm going to do, result is equals to, I will add the number. So a of I and then b of I. So I will add both the number and c dot append result. I am going to do only this thing. Now how to know what is the execution time? Can I write something like this? Import, let me write this here on the top. Usually time, any module whatever you want to import, this should be at the top of the script. So let's say import time, right? And then here I can just write start is equals to time dot time, right? And then end is equals to time dot time. You can also use perf counter, but let's say I will just use this time dot time, and then print. I will just write print the execution time. The execution time. The execution time is start minus end. So here I will just write, sorry, end minus start, end minus start. So just execute this, right? Let's see how much time it takes. I guess I have taken a lot of zeros. Okay, so the execution time is 4 seconds. First of all, is it clear, guys, so far? Is it clear? Right. Saurabh is saying how memory is reducing. I didn't saw your question earlier, Saurabh. Because here, whenever you are doing int 8, so it means 8 bits of integer. This is 16 bits of integer. By default, it is 32 bits of integer. You can also write 34 bits of integer, and that is how it is reducing. First of all, this code is clear. This should not be a problematic thing. Now, guys, the same thing I am going to do using NumPy. So here using list, we have understood this. Now I am going to do the same thing using NumPy, and let's see what will happen. So using NumPy array. Now, now let's see it using NumPy array. I am going to use here np.arange, right? So np.arange, simple. And here again I am going to use np.arange, arange, very simple, np.arange, and nothing else. So I will just remove this, and then what I am going to do, c is equals to a plus b. The moment you do a plus b like this, and now see the execution time is 0.43 second. Same operation, everything. Now you guys have to answer me, which is faster? Which is faster, guys? Which is faster now? Right, right. Is it list operation is faster or numpy array is faster? Right. Everyone has to answer this now. Is it clear, everyone? Yes or no? Right, 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 right. Is it clear, everyone? Say it, guys. Right, right. So again, it is proved that NumPy array is far faster than its contemporary, that is list. So far, so good, everyone. Right now, should we move ahead? Now, is it basics are clear? Everyone is happy till now. Say it, yes or no. Everyone is happy till now. Anyone who is not understood, right? So this time, you guys have seen with the practical implementation that okay, this is the reason, this is the fast, why the size is low. I have showed you everything in detail, right? Anyone has any question? Saurabh, do you have any question to ask? Anyone? Right, right, right. No one has any question. Very good, very good, very good. Right, right. Now guys, we should move ahead now. Right, we should move ahead. Now we are going to understand other things, right? How to make a NumPy array, what are the some operations on NumPy array. So we are going to see a lot of things now. So first thing, NumPy array, NumPy array creation, right? First thing, NumPy array will always be homogeneous. NumPy array will always be homogeneous, either integer or float or string, it doesn't matter, but everything will be of same data type. So let's start creation of a numpy array using a integer. So for example, let's say np.array. So if you do np.array and pass a list of element 1, 2, 3, 4, then you will see that this is an array of integer. Yes or no? This is enough integer. Quickly, yes or no? Say it quickly. Right? Right? Very good. Now, moving ahead. Now we have np.array, and now this time here I will just write 1, 2, 3, and then here I will put ajay. Now, if you see, everything becomes a string. So the idea is either it will be integer everything, either it will become string, right? What would be the priority? String will be the priority. Then float will be the priority, right? So let's say if one element is float, something like this, right? 1, 2, 3.2 or 3.4, then you will find it that everything has become a float. Clear? Right. So this proves that array stores the homogeneous data. Clear? Right. Now moving ahead. Right. So far so good. Let me see the chat once. There is no any questions. Okay, fine. So far so good. Not a problem. Now this array that you have made, right, is called as one dimensional array. So one dimensional array, what is this called as? np.array. If you do it, this is one dimensional array. Obviously I will speak about how to see that this is a one dimensional array or two dimensional array. I will talk about this, no need to worry about that. But this is your one dimensional array. But how to find out that this is one dimensional array? There is some attribute to find out. You don't need to worry about that. I will discuss this. But as of now, if someone asks you how to find that this is a one dimensional array, simply see that this is one square bracket, then this is called as one dimensional array. Clear? If one square bracket, it means one dimensional array. This is the easiest trick that I say to everyone in the class. Right, 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 right. Now, fine. This is your one dimensional array. But the point is how to visualize this. How to visualize the one dimensional array. How to understand this? This is very, very important. How do you understand one dimensional array? Right, right, right. Anyone has any idea how to understand this one dimensional array? So we have 1, 2, 3, 4. How to understand this? Right, right. So 1D array visualization. So I will speak about the visualization as well. Visualization. How to understand or what is the visualization of 1D array? Right. Very simple, guys. This is very, very simple. I am saying A is equals to 1, 2, 3, 4. Right. Simple. Make a x-axis like this. Make a y-axis like this. Right. Right. Now, what are the values? 1, 2, 3, 4. 1, 2, 3, 4. This is your one dimensional array. Simple. No matrix. No matrix. Guys, galat baat. Wrong thing. No matrix. Jyoti, Rajkumar, I will invite you to my house. Will give you a very good treat, very good feast. Will make you eat chicken biryani and paneer biryani. Then take you to the top floor, and you know what will you do after, what will I do after that? ऊपर से छोड़ दूंगा. I'll just leave you down from the top floor. Right, right. No matrix. One dimensional array means one dimension. One dimension means forget y axis. only x-axis. This is what I wanted to show you, and many people gets confused in this. And now this one dimensional means one axis. What is the meaning of this? This is nothing but mathematically this becomes a vector like this. So can I say one dimensional array is nothing but vector? 1D array is vector. Clear? Yes or no? Everyone? Right? Right? Now, very good. Can we make two-dimensional array? So now this was your one-dimensional array. Can we make two-dimensional array? Dimensional array? Dimensional array? Can we make two-dimensional array? Right? Right. Can we make two-dimensional array? Right? Right. The answer to your question is yes, we can make two-dimensional array. How? Simple. NP dot array. I had told you how to find that this is a one-dimensional array, number of square bracket. How to find it is a two-dimensional array, number of square bracket. Two square bracket. It means this is a two-dimensional array. 4, 5, 6. So this becomes a two-dimensional array. Simple. This becomes a two-dimensional array. Right. Right. Now, what is this two-dimensional array? Guys, this is the question. 1, 2, 3, 4, 5, 6. Now, what is this two-dimensional array? Let's try to understand this as well. Simple, guys. Very simple. Let's say 1, 2, 3. Right. Parallel to this, let's say there is another data point that is 4, 5, and 6. Now, if you just join this becomes your 2D array. And if you want to visualize it, just see the video. See the video. I am showing you a sheet of paper. This is nothing but a two-dimensional array. See, one paper, just see from the front side. This is your two-dimensional array. Clear? Yes or no? Right. I will not take this. I will take this. So I have only one sheet. See, only one sheet. So this is your two-dimensional array. Right? Clear? Yes or no? Everyone? Is it clear? Say it. Right. 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 Very good. Very good. Very good. Really proud of you guys. Very really proud of you guys. Now, moving ahead. Moving ahead. Can we make a three-dimensional array? Now, this is the question. Can we make a three-dimensional array? Three-dimensional array. Can we make this three-dimensional array? Right? 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 The answer is yes. NP dot array. NP dot array. And this time, I'm going to write something like this. 1, 2, 3. Now, in 3, let's say 1, 2, 3, close. Then we have 4, 5, 6, 4, 5, 6. Then we have 7, 8, 8, 9. Fine. This is the thing. Now what I'm going to do, right? Either I close it directly like this and see this is the np.array, or one thing more I can do. So let's say 1, 2, 3. Okay, let it be like this. So this is a three-dimensional array. Now, how will you understand? I will talk about this. But first of all, is it clear how to make a three-dimensional array? Now, how to understand this, guys? This is again very easy to understand. See it here, three-dimensional array, right? Three-dimensional array. To understand this, right? Think like this. There is one array like here. Let's say 1, 2, 3. Back to this, we have 4, 5, 6 array. Back to this, we have another 7, 8, 9. This is the way you understand. To make it more clear, I will take again that sheet of paper. See the camera. This is a sheet of paper. Now see, it has multiple sheet. One array, see here in the camera. Then again, second array, second sheet. Then we have third array, third sheet. Then we have fourth array, fourth sheet, and so on. So this is your three-dimensional array. Yes or no? Got it, guys, everyone? Quickly. Yes or no? Right? Is it clear, everyone? Right. I am coming to that, Praveen. I am coming to that. Don't worry. So this is your three-dimensional array. So three-dimensional array. Now, 1D array is a vector. 2D array is a 2D array is a everyone. You have seen 2D array somewhere. Matrix. 2D array is the matrix. What is three-dimensional array? Quickly. This is called as tensor. Obviously, you don't need to understand this as of now, but multi-dimensional array is called as tensor. Multi-dimensional array is called as tensor. Right? Right. 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 Is it clear, everyone? Right. So far, so good. Anyone has any questions till now? Should I move ahead now? Yes or no? Now, right? So this is the way you create an array. Till now we have seen. Now moving ahead, right, right. What are the other ways to create an array? Right, right. So we have other ways also to convert the to make an array. So for example, other ways to make an array. So another example is as array, which is actually deprecated. Right, nowadays it is not used, but np dot as array. If you write like this as well and provide a list, and you provide a list like this, 1 2 3 1 2 3, this will always also be an array. You can also do this. You have other way as well, as any array, right? You can do this as well. So example, np dot as any array, right? Np dot as any array, and you just pass 1 2 3. So this is also an array. But now the question is, what is the difference between as array and as any array? That's the difference. That's the question now. So as any array, right, converts the input to an n-dimensional array, right? But leave, 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 but leave array and its subclass as it is. Subclass as it is. What is the meaning of this? Right, right. So now, guys, as I had told you, 2D array is nothing but a matrix, right? So NumPy also gives the way to create a matrix. Example, np dot matrix as it is. Example, np dot matrix, np dot matrix. So what you can do here, just write np dot matrix. The moment you write np dot matrix, right, and you pass here value 1 2 3 4, this is your matrix. See it carefully. So what is matrix? You already know, we have discussed. It is a 2D array. So 2D array is called as matrix. So specialized, like matrix is a specialized array that is two dimensional. Now if you pass this in as any array, so let's say I will just put here a is equals to this and write like this a, right, right. So here you will get, so just a second, here you will get a matrix, fine. But as any array, if you pass a inside this, if you pass a inside this, it will remain matrix. It will not change to array, because as any array will convert everything to the array. If it is not an array, neither it is the subclass of array, and matrix is the subclass of the array. And that's why here, if you see, if matrix is passed as it is, it remains as it is. It is not converted to array. Clear? Yes or no? This point is very easy. It should be very, very clear. Can we make three-dimensional matrix? Can we make a three-dimensional matrix, guys? Can we make a three-dimensional matrix? Can we make three-dimensional matrix? Dimensional matrix. Quickly, can we make a three-dimensional matrix? Something like this or something like this. Can we do this? Right. If you try doing this, it will throw you an error. No, matrix cannot be three-dimensional because it is always 2D. Clear? Right. Now, we are seeing creation of the array. Now, moving ahead, how to convert a tuple to an array? So, let's say you have tuple. T is equals to something like this. Tuple. So, let's say here 1, 2, 3, 1, 2, 3, and let's say 4, 5, 6. You want to convert this to an array. How can you do this? Right. So, if you see type of T, right? Type of T, type of T, this will be a tuple. If you want to convert this to an array, how to convert this? Again, same way, np dot array, and this just do T, it will be converted to array. Simple. Right, 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 right. Is it clear, everyone? Right, right. Another way to create an array, right? We have other function to create an array, right? That is np dot from function, right? I will again come to this, but let's say np dot from function. What is the meaning of this? You can pass any function to create an array. So for example, here, right, creating array, creating array from function, from function, creating array from tuples. Believe me, guys, this much of cumulated concept you will not find anywhere else, because I was seeing how to teach data toolkit in a very best possible way, and I didn't find anywhere which clubbed everything at one place in a very structured way. So hope you have the maximum benefit out of it. So creating array from tuples, array from tuples. Already we have seen this. Now, moving ahead, from function. How can you do this? Right. So here I will write a lambda function. See it. Lambda, I comma j. Right. And then I is equals to j. I is equals to j. And I want an array of size 3 comma 3. Right. Right. Now, what is the meaning of this? I will talk about this in detail. But it means, right, construct an array, see here, construct an array by executing a function, a lambda function, obviously, executing a function over each coordinate. And now what is the function? Coordinate. If I is equals to j, so let's try to understand this. What is the meaning of this? So let's say here 3 by 3 is the shape. 3 by 3 is the shape means very simple, 0 1 2, 0 1 2. If I is equals to j is same, wherever 0 is equals to 0, it will become true. 1 is equals to 1, it will become true. 2 is equals to 2, this will become true. Rest, it will be false, because this condition I is equals to j, it means the coordinate of this axis and this axis is same. This is the understanding. Is it clear, everyone? Yes or no? This is the way also you can create an array. Right. Now I have a question for you. Right. Use, this is the homework, internal assignment. Use 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 np dot from function other than lambda function. Will you guys do this other than lambda function? Will you guys try it out? Right? Will you guys try it out? Very easy. Just provide any function. Write a function, provide here, you will be creating the array. Right? Right. Now, moving ahead, let's say this is the array. Now, can I, instead of getting true false, can I get integer? Everyone? So it is true false. Can I get integer? So let's try to look at this. So here if you see dtype is there. Dtype as an option. So what I'm going to do? So here I will just write dtype is equals to integer. Then you will get, okay, I'm not getting this. Oh, mhm. There is some issue. Dtype is equals to integer. Mhm. Okay, I will just try dtype equals to float. Dtype equals to float. Let's see it if that works, but it should work. Dtype is equals to float. Okay, I guess it is not working because of the condition, but let's say you can do it using the dtype parameter. So for that, what I'm going to do, I will just copy this particular function. Right, I will just copy this particular function to show you the example, right, so that it is okay for you. Right, so IG, so if you see 0101, so you can do that as well. Right. Right. One thing you can do, let's say I will store this in a variable a. So let's say a is equals to this, and then try int of a. Right. No, this is a dot as type int. So I'm just guys experimenting this. So you can do this as well. Right. So this is how, whenever you are having expertise on some programming language, if you are not able to do using one way, you can do another way. Right. It is just, the thing that will come with the practice, but you can convert this at the end of the day using this way, this approach as well. Okay, is it clear everyone? Yes or no? Right. 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 It's working. I don't know, Rajkumar, it might be my problem with recent update in Python or library, but anyway, it doesn't matter. So here it is now fine. Right. We have different ways to do things. So this is the one way. Now again, I can also play with this function. So now I will just show you another way to do this. So what I'm going to do, instead of I equals to j, I can multiply this as well, I star j. See, so I coordinates are multiplied and you are getting something like this. Right. 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 This is the understanding. Right. Right. Now we can have other way as well. How? Very easy way. So let me show you. So for example, we have np dot see it, np dot from string. So from string, this is again another option using which you can create an array. So for example, let's say here you will pass any value, maybe any value, let's say 12, 13, 13, and 14, right? And you pass one separator is equals to a space. Now if you see here, this will be an array. Remember to use this, right? Values should be numerical inside string should be numerical. So easy peasy, right? Can we create with other approach? Yes. So let's say you have seen range function. Already we have discussed range function. So range of 5, and if you just provide list, then it will give you a list of the values, right? Something like this, 0, 1, 2, 3, 4. Now what I'm going to do, right? So let's say I will make this any iterable, or let's say many any tuple, something like that. So let's say this is an list. Let's say list, or uh, Okay, what I will do, I will just make a tuple so that I can just show you. So I for I in range of 5. So I have made this particular thing. Now this is actually a tuple. So I will just show you. If I just show you like this, then this is a or a some sort of iterable, right? So here I will just write iterable. So maybe I will just write iterable, some iterable. Now I want to make an array with this iterable. How can I make this iterable? How can I make this iterable? An array. So there from in NumPy, again it provides you a function np dot see here np dot iterable. So from iter, simple. And then you will pass the iterable and whatever data type you want, you can put that. So this becomes integer, right? You give me other ways, any data type, I can make an array out of this. You can also make this with a separator. Let's say here we have separator comma, then you can just pass comma like this. This will again become an array. Right, 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 right. So these are different ways of creation of an array. Right. Another way, another way, right, right, right. What is separator? Piyush says what is separator? This comma is separator. How 12 and 13 is separated? Using a space, right? Here it is separated using a comma, right, right, right. Set. Okay, Tanya is asking set. So let's say A is equals to set 1, 2, 3. Right. So let's say A is set. Let's try it out if we can do this. NP dot array. Right. Let's see it. We can do this or not. Simply. So here, this is the array. Simple. From set. So this should not be here. I will put this somewhere here. So from set. From set. From set. Ask me any data structure. I will just make it. Right, right, right. Yes, Pius. Now, guys, can we make array using another approaches? Yes, you can also do that. Right. One thing is a range. What is this a range? Right, right. A range. Already we have seen similar to range in NumPy, we have NumPy, we have range. We have range. So if you remember, in range, you would not get any value. You had to do list first. You had to do list to get a range. You need to, in range, you need to convert or typecast, typecast to, to any data structure. To see the value. But this is not in the case of arange. No, arange has a different approach. It simply says do np.arange, np.arange, pass the starting value, ending value, and whatever you want, the space between that. See here, this is the array that you created. Right, right. So, what is this arrange? To generate a sequence of number. What is the meaning of this command? Very simple. Give me, right, numbers. Give me numbers or no numbers evenly spaced between 1 and 10 with a space of 0.2, with a space of 0.2. Simple. Yes, Pius. Start, stop, end. Similarly, we have line space. NP dot line space. NP dot line space. Simple. And then again, 1, 5, 10. What is the meaning of this? Give me 10 numbers, 10 numbers, evenly spaced between, between between array yaar between 1 to 5. Simple. So this is again an array. This will be again an array. See here. So these are the different approaches to actually create an array. Is it clear, everyone? So far, so good. Yes or no? Yes or no, guys, quickly. So this here string should be numerical. So here I can just write one more thing. For string, you have to use a split and then use this array, right? Apart from that, I guess creation of array is done. We have done how to create the array with all possible approach. So far, so good, everyone. Right, right. So far, so good. Right. Anyone has any questions in 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 understanding how to create NumPy array? So we have discussed every possible way to create a NumPy array. Now we will start with other things now. NumPy array is done. Very good. NumPy is done. One more thing is left, that is reshape. I will come to that, right? And some other way I will come to that as well. But but as of now, till now, the basic things are already done. Right. Right. Now moving ahead. Right. So now again, let's say we have created the numpy array. Not a problem, we have created the array. Now let's see other functions as well, but this time using different approaches. So first of all, I will start with simple things. np.ones. np.ones. What is np.ones? So let's say np.ones, I want every element to be 1 with dimension 2 rows, 3 columns. If you execute this, see, 2 rows and 3 columns, I got a 2-dimensional array. But what if you want 1-dimensional then? Right? What you can do? So let's say np.ones, try it out. np.ones, how will you do? Just write 3. See here, you got 1-dimensional array, right? So using np.ones, 2-dimensional array, 2-dimensional array. Here np.ones, you got 1-dimensional array, 1D array, right? Now moving ahead, again this is the different approach to create an array, but still you are creating an array, remember, right? You are still creating an array. Now we have again another thing. Let's say np dot zeros. Let's say this time 3 rows, 4 columns. If you want to do, right, it will throw an error because here we have to convert this into another bracket. So now if you see, all the elements are 0. So np.0, all elements are 0. Elements are 0. Right. Right. Again, if you want to have an identity array means identity matrix. Actually, identity matrix is like 2D matrix, 2D matrix or 2D array, 2D array where diagonal elements, elements are 1. Right. So what you will do? np dot identity, and here identity you want, let's say 3. So here you will get 1111, something like that. Right. Right. Anyone has any questions to ask so far? Quickly. So far so good. Yes or no? Right. 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 Very good. Now, guys, moving ahead. We move ahead now. So we have understood how to create NumPy array. One more thing is left. in creation of NumPy array. But you don't need to worry about this. I will talk about this, right? Creation of NumPy array using reshape. NumPy array using reshape. We will talk about this reshape function again in detail. But as of now, let's say np.arange is 6. So there will be 6 elements. But you want to make an array, right, in some other dimension. So dot reshape, maybe I want 3 rows and 2 columns. So here you can just do like this. Dot reshape 3 rows and 2 columns. The only thing that you have to take care that multiplication of this is equals to this. But anyway, I will come to this reshape reshape again in the class ahead. I will again come to this. But this now ends the complete creation of NumPy array. Clear everyone? Yes or no? Guys, should we take some break now? Right? Should we take some break? 2 hours has gone. So 10 minutes timer. Right. Is my voice now audible? Yes or no? Very good. Very good. Very good. So attributes of array. So till now we have seen the creation of array. And guys, actually, this recording I am going to put on Udemy because no any Udemy course has this much of detailed explanation. So hopefully, I think this will be a very good thing. But let's see. But now this is your attributes of array, right? Right. What is the attribute of array? So already we already know that in oops concept, right? We had class objects, right? What was attribute? Do you guys remember in oops concept what was the meaning of attribute, right? How many of you remember this, right? Right, very good. Variable or the data. So variable associated with the array, right? Variable associated with the array is attribute of the array. So now let's try to understand this is your array. Now I want to see what is the shape of this array. So you will just write a dot shape. So if you just write a dot shape, you will realize that this is only one dimensional, and here we have three values in the array. This is one dimensional array. I will show you how to get the n dimensional array, but this means simply you have only three columns. Here, one dimensional is a little bit of a different types of interpretation. It has a different type of interpretation, but this is the understanding, right? Hmm. Right. So this is the understanding. Now we have another array. So np dot array, np dot array, right? Np dot array. So we have 1, 2, 3. 1, 2, 3. Then again we are going to have something like this. And now I am going to write 4, 5, 6. And I will close to this. So this is your, let's say, array B. So B is equals to this. And now if I just write B dot shape, so this will be, see here, if you see here B, you will realize that it has two rows and three columns. That is what I told you. If for one dimensional, the interpretation becomes little bit tricky, but you don't need to worry about that. But after one dimension, for two dimension, it is very, very much obvious. Two rows and three columns. So two rows, right, and three columns. Is it clear? Yes or no? For one dimension, it is becomes a little bit tricky to understand, but after that, this is very easy to understand. It is easy to interpret. Right now, moving ahead. So this was first attribute. Now moving ahead. So let's say you want to see other thing. Let's say b dot ndim. What is the dimension? So this is two dimension. Why? If you see two square bracket, that's why it is two dimensional. Now you want to see the size, right? So b dot size. What is the meaning of b dot size? It simply means how many number of elements you have. So if you just write b dot size, then you will realize 1, 2, 3, 4, 5, 6. You have 6 elements, right? Is it clear? Everyone, so far so good. Yeah, till here there should not be any problem in understanding. Everyone. Clear? Yes or no? Batao everyone. Everyone, please say it. Yes or no? Is it clear? Ada, Adeline, any problem till now in understanding? Right? 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 Very good. Very good. Very good. Now, guys, moving ahead, we have another option, b dot item size. So if you just write item size, you will get something 4. What is the meaning of item size? Array dot item size. So this is another, right, method. So returns the length of one array element in bytes. So please remember this. This is very important. This size was number of elements. This was here length of one array element in bytes. So this is the understanding, right? This is the understanding, right? Clear? Yes or no? Everyone? Is it clear? Right. Second thing, next thing. If you want to see the data type, what is the data type? So b dot d type. If you just write b dot d type, it will show you that it is integer 32. Right. So this is integer. The data type is integer. So far, so good. Everyone, everyone, clear? Yes or no? Right? Right? Yes or no? Right? 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 Very good. Now, guys, since you have understand this, I will again go back to again creation of array, because I couldn't talk about these things without making you understand the attribute of an array. Once attribute of array is clear, then one more thing needs to be discussed here before this attribute of the array. So here, while creation of an array, right, we had seen few things. What are the things that we saw? np dot zeros. So here by default, it was a 2D array. Can we create a 3D array in this? That's the question. np dot ones we have seen, right? Can we create np dot ones 3D array? Since we didn't had n dimension, that's why I didn't had spoke that point of time. But now let's see it, right? So let's say here you want to have. So I'll just show you np dot zeros. So you know np dot zeros. So let's say 2 comma 3, it will give you np dot zeros, something like this. If you want np dot ones, np dot ones, it will give you like something like this, 3.4, right? So next thing, can we have np dot twos? Everyone, np dot twos, right? Can we have np dot twos? Right? Right? No. The answer is no. You cannot have np.2s. You cannot have np.2s. np.2s. That is completely fine. Till here we had understood. But now the question is, can we have three-dimensional zeros? Can we have three-dimensional ones? And to understand this, now it is the right time to show you. So np.identity, I will just put it here. Right, right, right. So here I will just write zeros, ones in n dimension. N dimension. So for example, let's try to see it. np dot zeros, when you were writing like this, so you were writing like this: 3 rows, 4 columns. So here 3 rows and 4 columns. Let me write ones because I don't like writing zeros. So np dot ones, 3 rows, 4 columns, 1 1 1. Not a problem. What is the dimensional space? It is a two-dimensional space. Remember one thing that is very, very important, that three-dimensional array is made up of two-dimensional array, and two-dimensional array is made up of one-dimensional array. Very, very important. So I'll just write it a comment here. Three-dimensional array, three-dimensional array, three-dimensional array is made up of two-dimensional array, two-dimensional array, and two-dimensional array, 2D array is made up of 1D array, made up of 1D array. Now, to understand this clearly, it is the right time to make you guys understand this. How? So I will show you. So let's say, what is the interpretation of this? np dot ones, 3 rows, 4 columns. By default, it becomes two-dimensional. Now, guys, see it carefully. np dot ones, see it. np dot once here 3 rows and 4 columns. I want to increase this in one more dimension. Now see here what happened. See it carefully. np.1, the moment you wrote extra 1, so here if you see there are 3 square brackets. Here it was 2 square brackets, right? So 2 dimensional. Now if you see 3 dimensional, right? Right. So here I will do, first of all I will store this np.1's a, right? np.1's a, and now, right, right, or let's see what I will going to do, or let it be like this, let it be like this, doesn't matter. So np dot once 3 rows 4 columns in one dimension. So this is how you get. Now how to understand this? Very simple. 3 rows 4 columns, this is the understanding, right? Right. So see here, 1 2 3 4, each of this column has become a 2 dimension. See, this is the 2 dimension. So this is what I mentioned, every 3 dimension matrix is made up of 2 dimensional matrix, and inside this 2 dimensional matrix everything is 1 dimensional. This is the understanding. This is the understanding. Let's see another example. Let's see this time np dot zeros, np dot zeros. So let's say np dot zeros, and this time I am saying 1 rows, right, 3 column. Let's say this is your 1 rows 3 column. But now I want this in one extra dimension. See here, 3 dimension. Right. Right. Now if I write 2 here, what will happen? This 0 0 0 will be repeated. See here, 0 0 0 will be repeated. But what to understand? How to understand this and how to understand this? Right. So to understand this, you have to think in a opposite way. How to think? This is fun. Right. Start thinking in this way that 4 rows, 4 rows, 1 column, right? 4 rows 1 column in the third dimension. I will repeat it again, don't worry about that. To make you guys more understandable, just keep 1 like this. I don't wanted to give you this example because in the mindset it is stuck that 1 dimension is always kept here. No, that is not the correct thing. It can be anywhere. The interpretation will change. But here let's say 1 row 1 3 4, it means 3 rows 4 columns. So 3 rows 1 2 3 rows 4 columns. 1 column, second column, third column, fourth column. So here I will write 3 rows 4 columns in the third dimension. It means this is your third dimension. Here in this case, 3 rows 3 rows 2 columns 2 columns 1 dimension in the third dimension, or let's say an extra 1 dimension in the third dimension. Very simple to understand. Actually what happens, if a teacher has to teach, he or she can teach in a very simple way. Just write a is equals to this and just write a dot ndim, right? If it does like this, this is 3 dimension and hence proved. People actually themselves prevent explaining in this way because just they will show you a dot ndim. Now student will be very happy that they got to know that this is the dimension, but the correct understanding is 3 rows 4 column in the third dimension, 3 rows 2 columns in the third dimension, 3 rows 2 columns. Okay, this is not the thing, but yes, this is the understanding. If you want to have more dimension, I can show you that as well. So I will just copy this np dot zeros. Let's say this time I will write repeat 2 times. See here, 3 rows 2 columns repeated 2 times as the third dimension. So I'll just write 3 rows 3 rows 2 columns repeated 2 times 2 times in third dimension, or 2 times to create the third dimension, to create third dimension. And that's why it proves 3 dimension is made up of 2D. 2D is made up of 1D. 1D, right? If you want to have more dimension, I can show you that as well. So let's say this time 2 rows, 3 columns, sorry, 3 rows, 2 columns, repeat 2 times with one more dimension. So see here, this is now fourth dimension. Keep repeating, keep giving extra values, it will keep repeating itself. So now here let's say b is equals to this, and now this is b, and if you now create, if you just like this, b dot ndim, so this will become 4 dimension. Now again, let's say again, try to see another example. np dot zeros, this time again, what is the repetition? What is the meaning of this? 3 rows, 2 columns, repeat 5 times, and here repeat 2 times. See, this is going to be so much of fun. See here, 3 rows, 2 columns. So very, very important, guys. See here, 3 rows, one, two, 3 rows, 2 columns, 1 column, second column. 3 rows, 2 columns, repeat 5 times. So first time repeated, second time repeated, third time repeated, fourth time repeated, fifth repeated, and then again repeat the whole thing again 2 times in the fourth dimension, and that's why you see the second repetition of everything. So again I will write it here: 3 rows, 2 columns, repeat 5 times, right, in third dimension, for third dimension. Actually in word is wrong. For third dimension, and 2 times, and repeat 2 times for fourth dimension. Is it clear, everyone? Right, right. Is it clear, everyone? Rajkumar, see it carefully. It is not nothing major thing here. Just teaching the dimensions: 3 rows, 2 columns. If this will be third dimension, this will be fourth dimension. Everyone, is it clear, guys? Quickly, will you ever forget this? Right, 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 right. Very good, very good. Okay, okay. Now moving ahead, guys. Moving ahead. So NumPy has been really. So we have seen the integer also, but now let's say if you want to convert this, changing the data type, how to change the data type, changing the data type. Already we have seen this, but let's again here b dot as type, and here you can just write, let's say int 16, right? Okay, int 16 is not defined. Okay, you just do np dot int 16, and this is how int 16 will be converted, right? Right, right. Now comes the next bigger thing. We have discussed one thing, attributes done. We have discussed reshape, but not discussed it completely. So now it is the right time to discuss the reshape. What is the reshape? Right. What is the meaning of reshape? We will be discussing everything in detail. Right, right, right. So now here I will just write reshape of array. Right, right. Now, now, right, or array operations, array operations. In this array operations, we will start with first reshape of array. Right. Now, guys, let's start this. So first of all, np dot array. This is your np dot array. I will make an array. let's say I will make an array. So let's say uh, 1, 2, 3, and then 4, 4, 5, 6, then 7, 7, 8, 9. So this is an array. A is equals to this, and if you see, A is this array, right? So guys, now you have already seen the attributes of the array. So A dot shape. What is this? 3 rows, 3 columns. A dot size, right? Size is nothing but 9. There are 9 rows, right? And then we can have, let's increase this. Maybe I will increase this. Instead of 7, 8, 9, now I will just have 10, 11, 12 as well. 10, 11, 12, right? So this is A dot shape, 4 rows, 3 columns, and something like this. And then A dot size. Okay, size I have written. Very good. I just required, or A dot ndim. So n dimension. What is the dimension? This is 2. Right. Now, guys, I want this array. Let's say this has how many rows? 1, 2, 3, 4 rows. I want this 4 rows to be 2 rows. Can I do that? Can I do that? Can I do that? Quickly, everyone. I want to convert this array from 4 rows to 2 rows. Can I do so? The answer to your question is yes. How? So A dot reshape provides you the benefit of reshaping, provides the functionality of reshaping. So you can reshape. So you want 2 rows. Fine, not a problem. But there is a catch. Right, right, right. You can provide, you can provide the dimension, dimension of array. You can provide the dimension of array in the reshape only if the product if the product if the product you can provide the dimension of an array in the reshape only if the of product is equals to size of the matrix. What is the meaning of this? So size, if you see, is 12. So if you want 2 rows, then you need to have 6 columns. So 2 into 6, 12. And if you see, now this has been transformed. Why? This is the rule. Because you don't want to lose the data. Because you don't want to lose the data. Lose the data. Another example, let's say you want to reshape it, A dot reshape, right? A dot reshape. Now this time you want 3 rows and 4 columns. Can you do this? So yes, here I can just write 3 rows, 4 columns. Can you do it 12 into 1? Yes, you can do it, right? But can you do, let's say, 5 to the 10? 5 rows, 2 columns. Can you do this? Or 3 columns? No. No, because the multiplication is not same. You cannot have extra data, you cannot lose data, and that's the idea. Is it clear, everyone? Yes or no? Right, 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 right. Very good, very good. Now guys, moving ahead. So we have understood everything so far, right, right. But let's say if you don't know any, if you don't know what would be the rows and columns, in that case what you will do, right? So just check it. A dot reshape, Let's say you want you want 3 rows, but don't have any idea about how many columns are there. You just put -1. NumPy will take care of that. Even if you put -2, it doesn't matter. Just put any negative value. Just put any negative value. Negative value. Python will determine, NumPy will be determining this. So for another example, let's say you are sure that 2 should be number of columns, but you don't know number of rows. Then just write anything -100. It will just do the required thing. Clear? Yes or no, guys? बताइए. So far so good. सभी को समझ में आ रही है चीजें? Everyone till now, is it good? So far so good, right? Right, right, right. Very good, very good, very good, very good. Now, guys, moving ahead. So we have understood a lot of things. Now we are going to see another thing now. Right, 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 right. What is the other thing that we are going to look at now? We are going to see other other operations of array, right? Other operations of array. What are the other operations of array? So let's start with that. So first operation that we are going to see is arithmetic operation, or let's say scalar operation. That is your operation, that is arithmetic operation. Inside arithmetic operation, this is your scalar operation, right? So now let's say you have an array, something like that. I already have this array. So let's say this is your array. Fine. This is your two-dimensional array. Now you want to add all the elements of this array with 5. What we can do? A plus 5. So if you just do this, this will be 5. If you want to multiply everything with 5, a multiplied by 5, so you will get like this. If you want to subtract -1, you will be able to subtract. Right, 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 right. This is the understanding. One more thing, identity matrix. Where it is identity matrix? Aja bhai, identity matrix. Where is identity matrix? Reshape attributes of array. There should be an identity matrix. Np dot ones zeros. Np dot zeros. I have lost identity matrix, line space, once. But anyway, I guess identity, identity, identity. There was identity. Okay, very good. One more thing, guys, in this identity matrix, this can be achieved, something like this as well. Np dot I. So if you just write like this, so this will be a three-dimensional element with one at the diagonal. So return return a 2D array, 2D array with ones on the diagonal element. So this also you can just do it. It just came to my mind. So you can do as this well as well. You can also convert this to integer. So how can you convert? Right, np dot I dtype equals to integer. Just write np dot I dtype is equals to integer. Dtype is equals to integer. You can do this as well. Right. You can also have another option, that is empty, np.empty. What does np.empty do? Right. So if you just do this, return a new array of given shape and type without initializing entries. It simply means any random array it will just give you. So np.empty 3 comma 4, 3 comma 4. So it will return anything randomly. So it is 000, something like that. Right. So this is also something that you can look at. But anyway, our discussion was some scalar operations that we are going to look at. So you can just do a plus 5, a multiplied by 5, a minus 1, everything you can do as of now, right? Now moving ahead, if you can just do it now, these things, let's move ahead. Can you do other things as well, right? Right, the answer is yes. So other thing, let's say comparison operation, that also you can do. So let's say a is there. So if you want to see a is equals to maybe let's say uh, a is equals to let's say 2. See here, only this value is true because at this point of time, at this here, you will find there is 2. So this is comparison also you can do, right? Right, you can do this as well, right? Now moving ahead, so let's say if you want to raise the power, can you raise it? Yes, you can do that as well. So let's say this is your a, you want to raise this power a exponential a. See here, you can do this as well. So is, can you divide? So let's say a divide 2. See what happens. You can divide as well. Can you have floor operation? You can do that as well, right? So all of these arithmetic operations are possible here in the case of array. Clear? Yes or no? Till now, anyone has any doubts so far? Quickly, guys. Any doubts so far? Everyone clear till now? Now we can move ahead with other things as well. Anyone has any questions so far? No questions so far? Quickly. Right, right. Very good, very good. So now let's move ahead, guys. Let's move ahead. Right, right. Now let's say if you have some values, right? I will just take any value. So okay, I will just make an array. So a is equals to, right, cross multiplication. Don't worry, I will come to cross multiplication as well. So a is equals to, let's say, np dot array, np dot array, and this time the value is, let's say I will just write p. P is equals to np dot array, and these values are right, 2.3, 4.2, and 6.1, right? So these are the p, right? Now what I am going to do, np dot round. So can I make it a round? Right. So let's say P. See here, 2.3 has become 2, 4.2 has become 4, and 6.1 has become this. So you can do this as well. Right? Right? Right. So you can do this as well. Now, since we are talking about arithmetic operation, can we do something like this? So let's say A is there. Can you do sum of A? Everyone? Can you do sum of A? The answer is yes. See, the sum is 22, 26, and 30. How it has came? Right, right. So here if you see 1, 4, 1 plus 4 plus 7 plus 10. This is the column wise, and if you do it the sum, you will get 22. Then this you got 27, and this 30 you will get 30. Now guys, one thing that is weirdo from rest of the thing. Here, remember guys, 0. So I'll just write here one thing. So let's say here you got everything, right? So now sum of A, I will show you one more thing. Sum of A, and here I will just write axis equals to 0. This is something weirdo, but you will find it. Why it is not there? Okay, this will not be there in this case. I will come to this. So I will come to this. But this is your A, right? Now maybe let's say mean of A. You want minimum of A, right? Okay, guys, what is happening here? Mm-hmm. Sum of A. A is there. Okay, so let's say maximum of A. Is this my A changed or what? A. Mhm. Mhm. Mm. Oh, guys, sorry, guys, sorry. So this would be np dot sum. I'm so sorry. So np dot sum. So here you will get 78. So this is your A. So np dot sum is 78, right? I was missing this, guys. Np dot max. Max of A is 12. So in this array, 12 is the maximum value. That's why you got the maximum value. Np dot mean. So if you just do np dot mean A, this will be 1. So what was happening earlier? I was using Python's function. But now, fine. So this is your A, right? Now I want to show you something. So let's say 1, 2, 3, all summed up, you got 78. All summed up, you got 78. But what if I want to get the sum that you were getting earlier? 1 plus 4 plus 7, something like that. So sum, here I will just write sum of A. So using Python sum, using Python sum, Python sum. Here using NumPy sum, using NumPy sum, NumPy sum. Right now, if you want result something like this, then how can you get this? Right, this is very interesting. So here what you can do, np dot sum, np dot sum, right? You will pass A, and here you will pass x is equals to 0. Now if you see, you got the same result. But there is this very weird situation, that here in the case of array, in case of array, axis equals to 0 means column wise, means column wise. Remember, guys, this is very important. In case of array, axis equals to 0 means column wise. But in pandas data frame, as we move ahead, axis equals to 0 means row wise, right? So that's the confusion, but don't worry about that. So now if you want, right, right, if you want, right, right, row wise, then you can just write x is equals to 1. You will get some row wise, 3 2 5 1 6 6 4 plus 5 plus 6 15 7 plus 8 plus 9 24 and so far, so on. So this is the understanding that you should have, right? This was tricky, right? Right, but remember this, x is equals to 0. Here you can just get like this. Is it clear, everyone? Yes or no? Right now, if you want to have product of everything, so product of A, prod of A, you will also get, array yaar, why I am not writing np.prod? So np.prod of A, you will get the multiplication as well. Again, similar way, np.prod, np.prod, you can also write x is equals to 0 and x is equals to 1. By default, x is equals to, no, there is no by default here. So x is equals to 0 or 1. You can write that as well. In similarly, minimum also, you can just write x is equals to 0 or 1. So that you guys have this in mind, that anywhere in main max you can write x is equals to 0 or 1 like this. This is the understanding. Now moving ahead, let's see some statistical properties, statistical calculation, statistical calculation, calculation. So you can also look that. So for example, here, now this is your array. You want to see the variance. So np dot variance, np dot variance of A. So you can get the variance of A. So here you will get np dot variance. Now again, you want for column wise, then you will write x is equals to 0. X is equals to 0. So you will get the variance column wise. If you write x is equals to 1, you will get row wise. X is equals to 1, you will get row wise. And this is the understanding, right? Not only this, if you want mean value, np dot mean, so again A, again you can also pass the axis information. Hope you understand that you can use axis as many a number of times you want, right? Now median, np dot median, median, axis, let's say I will just write A only, median. You can also have np dot, right, standard deviation. So you can also write as standard deviation, something like this, np dot standard deviation of a. Again, you can put x is equals to 1 or 0 if you want. So x is equals to 0. X is equals to 0. Clear, everyone? Yes or no? Say it quickly, guys. Say it quickly. So far, so good. Should we raise the bar? Should we raise the bar? Right, right. Very good. Let's see log and exponents then. So can we have exponential of this value? So np dot exponential. You can also do that as well. So np dot exponential. You can also have x is here as well. X is equals to x is equals to 0. You can do that as well. Np dot exponential. A why it is so? Np dot exponential. So let's see the value. Okay, there is no any option of axis here, so not a problem. Leave it as it is. So this is your axis like this. You can also have log np dot log of a. You will also get this value. You can do this as well, right? Right. You can have trigonometric functions as well. So let's say trigonometric now. Trigonometric. You can also do that. So let's say np dot sine. Np dot sine. This will be your sine value. Np dot cos. You will get also the cos value. Np dot tan. I don't think tan exists. Tan doesn't exist, guys, because sine by cos is be 10. Okay, 10 is there. Very good. Np dot cot. Let's say cot is there or not. Right. Okay, very good. Cot is not there. So reverse of sine cos tan is cosec, sec, and cot. That's why all of these three is not there. This is just class 8, 9, 10 basic mathematics. Is it clear so far? Right. Yes or no? Very good. Very good. Very good. Very good. Right. Right. Very good. Now, guys, moving ahead. Right. So, can we have round? We already have seen, right? Already we have seen, but we are having, let's say, maybe uh, ceil function. I don't know how many of you know ceil. So np dot ceil. So let's say a, right? So it is also possible. What is the ceiling function? Then we have np dot floor as well. Np dot floor. So let's say instead of a, let's take p. Okay, very good. P np dot floor. Then I can just have p again, and then np dot round. What is the meaning of this? I will talk about this in detail. So, what is P? I will first show you P, because this P will help you to understand. So, this was P. Now, guys, see here, right? What is ceiling? What is floor? So, Ceil means, right, ceiling of your room, or let's say this is your room. So, this part is your ceiling, right? Similarly, here 2.3. 2.3, if you round, either it can be 2 or it can be 3. So this 3, right, this 3 is actually ceiling, ceiling, and this 2 is the floor. In a room, this value is ceiling and this is floor. Let's say this is your room. So 2.3 higher value will be ceiling. That's why 2.3, 3, 4.2, 5, 6.1, 7. Floor lower value. So 2.3 becomes 2, 4, 6. Round, here I have written wrong. Why I have written 2, I don't know. But let's say here P. So here round simply means that what is the nearest round value with some rules. What is the rule? If after round value there is 5, 2.5, it will be 2. More than 5, then it will be 3. Also there are some other rules. If it is after 5, there is some even value here or odd value, I don't remember exactly, but those rules are also followed. So these are ceiling, floor, and round. This is the understanding. Right, right, right. Is it clear, everyone? Yes or no? So far so good. right, 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 right. Very good, very good, very good. I hope everyone has understood this. Right. Now, guys, let's see few more things. Right. So we have seen this, right? Trigonometric and all of those things. I will again go back to this particular reshape function. So we have seen this reshape, right? Reshape was very good. We have understood this. Other ways of reshaping. I also want to show you some advanced concept, other ways of reshaping, right? So now, since we have studied statistical property, that's why I'm coming back to this again. So this is your what? What is this, guys? Can I say this is a matrix? Yes or no? This is a matrix. Matrix, right? So you can also transpose it. What is the meaning of transpose? So let's say this is 1 2 3 here, then this is row, this become like a column. 4 5 6, 4 5 6, it will become like this. So you can also transpose. Transpose is again a kind of reshaping. So again I will come to this. So here I can just simply write a dot reshape, not like this. Let's say np dot transpose. So here I can just write a, right? So you can just see here 1 2 3 has become a column. Same thing can be done in a short form a dot t. Same result will be achieved. One more thing, that is ravel, right? Ravel. A dot ravel. This I don't wanted to teach here, but let me explain this. A dot ravel. What is this ravel? Very interesting thing, right? Right, right. Reduce any dimension array to one dimension. One dimension. Very easy. Execute this. This has been done. And if you see 1 2 3 4 5 6 7 8 9 10 11 12, this is the understanding. The same thing can be also achieved using a dot flatten. So if you use flatten, does the same thing. A dot flatten. See here 1 2 3 4 5 6 7. Right, right. So what is this? A dot flatten. Return a copy of the array collapsed into one dimension. So this is also possible. I just wanted to show you further two more important things here in this case, right? Right. So since this is also a reshaping, that's why I showed you here, right? Right. There are some other things also about reshaping, right? I don't know. I should teach here only, or I should teach. Uh, okay, I will teach here only. This is again a very interesting thing. Very interesting thing, right? So again, this is related to reshaping only, right? Because you are shaping the array, right? You are reshaping the array, and this is very very important. So let's try to understand this again. So there is one thing that is called as expand dimension. So I'll just show you expand dimension. Expand dimension. So basically, you want to expand the dimension. So here we have seen the dimensions, how many dimensions are there. But now if you want to expand the dimension, can you expand the dimension? The answer is yes. Right. So for example, let's say I want to write np dot array, np dot array, right? Np dot array. Now here I will just write 1 2 3 4. So this is your, let's say, array is equals to like this. So this is your array. So this will be your one dimension. So array dot ending. So if you just look at this, this is your one dimensional array. But if you want to make two dimensional array, what you can do? Now don't say I will just increase the square bracket. That is one way. But if you want to increase this, then what you can do? Array dot expand dimension. Expand dimension. So array dot sorry, np dot expand dimension, np dot expand dimension. So np dot expand dimension, and you can pass this array, right? Now here, if you use this, it will give you an error, because here you want to pass axis equals to 0. So here this will increase the dimension like this. Now again, I will show you with the help of two dimension. So this is your axis equals to 0. You can also pass axis equals to 1, right? This will be very clear if two dimension. I will show you. So 1 2 3 4. So here increases the dimension by 1, provided access in provided access in provided access. Now, to make you guys understand it in a more better way, what I'm going to do, a is equals to np dot array, right? And I will make a two-dimensional array. So 1 2 3, and then I will also write 4 5 6, 4 5 6, and then finally I will just write 7 8 9, and I will just close this. So this is your array A. Now this array A, I want to expand this. So np dot expand dimension. So I'll just write, copy this, np dot expand dimension, and I will write like this. So np dot expand dimension, np dot expand dimension, np dot expand dimension. Array yaar. np dot expand dimension. I will just copy this. By this time, I would have typed it. So np dot dimension, and this a is there. So now if you see 1, 2, 3, it was two dimension. So now if you see, it is a three dimensional space, right? So it has converted itself, right, into three dimension, right? How to see? Again, square bracket, or just do n dimension. So always remember, increase the dimension by one dimension, it will increase just one dimension. There is no way to increase multiple dimension. Similarly here, you can also have axis equals to 1, so it will increase this dimension, something like this. See here, like this. So this has been increased dimension here in this case. So not array, this is a. So this is your dimension. See here, three dimension like this, three dimension like this, three dimension like this. So axis equals to 1, already you know it is a row wise. That's why you see row wise dimension has been increased. Row wise dimension has been increased. Actually, this is also a part of shape of array, reshaping of array. That's why I taught you here as well. Is it clear, everyone? Yes or no? And opposite of expand dimension is squeeze. So you can just write np dot squeeze. So np dot squeeze, if you write it like this, then here if you see, this has been squeezed like 1 2 3 4 5 6 7 8 9. So it will be you know this is something bad, I guess. This result is not good. Remove excess of length 1 from a, right? So remove excess of length 1 from a, right? Okay, maybe what I will do, this is b is equals to this, and now I will also write b dot squeeze. Generally you don't use this one dimension increase and one dimension decrease, you will never use it, but let's say these are the functions that is there. So np dot b squeeze. Okay, so this is not working well as is expected. Maybe this is only for no error like input data no let us the integer length 1 in the shape if an axis is selected with the shape. So maybe what I will do, I will just pass a shape axis equals to 0, and now no, axis doesn't work here. Remove excess of length 1 from a, right? Remove x. So okay, just leave it, space doesn't matter much. So anyway, so this is again a squeeze function. So now this is the complete. Actually, one more thing I remember now, sorry guys. Each time I am saying reshaping is completed, but each time I repeat, remember another function. So one thing also you can do, np dot repeat. This can also be used. So let's say you want to repeat a 4 times. So this is also possible. So this is has been repeated 4 times. So let's say a. So what was a? If you guys remember, 1 2 3 4 5. So all the elements, so 1 1 1, 2 2 2 has been repeated, and it will just convert this to into one dimension. If you want to repeat in one dimension, you can do that as well. So you want to repeat this in two times with x is equals to 0 or x is equals to 1, or anytime, whatever time you want to repeat x is equals to 0, you can also do this. So this way you can repeat rows 2 times like this. Right, right. So this is the understanding. Right, 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 right. Is it clear, everyone? So far so good? Everyone tired now? Yes or no? Everyone got tired. Survi says, Piyush says yes, sir. Jyoti says yes, sir. Are you guys saying that you are tired or you have understood everything? Okay, okay. Praveen says little, little. Okay, no worries. So we are going to see the last function for today, and then we will actually stop after that. Actually, I wanted to okay, just let's see the last one and then we will stop. Okay, not a problem. So last function that we are going to see is, since we have studied repeat, we have another function called roll. So a, so this is your a function, and roll simply means shift one place towards up or down. So here you can just write np.roll a, and then let's say -1. So if you see here, 1 2 3 was there, right, right, and then we had 1 2 3 4 5 6 and 7 8 9. So one place shift, so -1. So 147, right? So this 147, right? This 147, right, right. So this has been actually changed. How? So this 147 has actually came here, 258 is there, 369 is there. So this has come to the last, but there is one change, 471, this would not be there. So maybe what I will do, right, so here I will just clear -1 and let's see 1. So 936, so 963, right. So one element is shifted. So anyway, doesn't matter. So one element is shifted. So you can just write -1 and one element is shifted. Now, if you wanted to see the two elements shifted, so np.roll, in fact, you can just write -2, -2. So these are the things that is not actually used, right, much, but people just for overall, right, one element shifted, then we have two elements shifted, just to make sure that you have some idea about everything. Two elements shifted in Python. I'll show you, there is a direct function called dot shift that you can use it and you can just get this, right. So that is the understanding. Here, one more thing, you have also x is equals to 0 or 1. So let's say np.roll here. So I will just do one thing. I have one array. So I'll just show you one array I have. So this is, let's say, one array. C is this. So this C is 1 2 3 4 5 6, something like this. So np.array. Here I can just write C and 2. C and 2. So this positive value, if you pass, it will be uh, C np.array. What I am doing, np.roll. If you provide C, then it will shift to left side. So let's say here 1 2 3 4 5 6 7 8. So 7 8 has gone up and this has gone down. So this you can just do this. Now here you can just write x is equals to 0 as well. So x is equals to 0, right, or x is equals to 1 is by default, but let's say x is equals to 0. Again, if you see, this will be shifted some other fashion. So 5 6, then again 7 8, then 1 2 and 3 4, right. So this is the understanding. So this would be the roll function. I had more functions in reshaping, but I think I will be taking that, or I'll just complete this very small thing, right. In the reshaping, it is called as stacking, right, right, stacking. So this is something also very important. This is stacking. What is this stacking? So let's say this is your array, right. Now I will also make another array. So what I will do, this is your C, right? np dot array, or let's say I will just make an another array B. So let's say B. So let's say B is there, and this time also I will make an array, right? np dot array, and this time one two. Okay, I will just remove this, guys. This is very bad. So B is equals to this and this np dot array. So now this np dot array 1 2 3 4 5 6, I will just copy this. I will copy this. I will put it here. So here this time I will just put 11, 12, 13, 14, 15, 16, 17, 18. I could have used that function as well, but let's say this is your np dot array. This is your A and B. These are the array. So now there are two ways to stack, either horizontal or vertical. See the camera once. Horizontal means, so let's say this is an array, one array. This is horizontal. This is your horizontal, right? What is vertical? One above one, top of it. This is vertical, right? Horizontal, vertical. You already understand this. Now, if you want to do horizontal stacking, just simply do what you have to do. So let's say here, I will just write horizontal, right? Horizontal. So let's say here I will just put it like this. So np dot h stack. So if you just do np dot h stack, right, and you pass both the array, so A comma B, so this will be a horizontal stack side by side. So this becomes your horizontal stack side by side, side by side, right, right, right. Now if you want vertical stack, right, you can do that as well. So np dot v stack, np dot v stack, and here you can just write again simple thing, right? A comma B. So on top of it, top stacking, top to top stacking. So let's say top to top stacking. So now this you will see 1 2 3 4 5 6 7 8 9, and then 11 12 13. So this is your vertical stacking, right? So horizontal stacking and vertical stacking. Now last topic for the day is splitting. Again it reshapes the array. That's why this is the broader umbrella. So let's say here we have A. The rule is always split will be equal, right? Be it rows or columns. So let's say here I want to split this array into three groups. So I can just do A dot h split, h split. So A dot h split, sorry, np dot h split, and A here I want to split this in, let's say, three groups. See here, three groups it has been splitted. One group, two group, three group. If you want to split this in vertical way, so you can also do, right, v split. So np dot v split, and if you just do this v split, and let's say you want to again split into three groups. See, this is a vertical split. So 1 2 3. So I will just show you A in, just to make sure you understand. 1 2 3. So here 1 2 3 here. So this is your vertical split. Then 4 5 6, then 7 8 9. Right. So if you just now put four groups, right, it will throw you an error. Why? Because you cannot divide this array, whatever array you have, into four equal parts. But let's say if you have uh, you know array something like this. Let's say maybe A is equals to np dot array, np dot array. So let's say if you have array something like this, right? 1 2 3 4, and then here I will just write 5 6 7 8, and then I will just copy this. So I will just copy this, I will repeat this again, right? So I'll just repeat this something like this. So I've repeated like this. So this is your, let's say, Z. Z is equals to this. Now see the magic. So this is your Z. Now if you want to actually split, so what you can do, np.v split. So now you want to split this into four parts, you can do it. So four parts you can do it. Okay, Jad. I tried Jad. Sorry, guys. So Jad. So four parts. It has been split into four parts. You want to split in three parts. Sorry, two parts. It will be also done two parts. But the moment you write three, again it will throw you an error, because equal partition is only possible and 3 is not the equal partition. So this is the understanding. This I will stop here, and we have covered everything in detail. I don't think anywhere on the internet in one video you will get this much of detailed explanation. So that would be all for this lecture. In the next lecture, we are going to see indexing and slicing. What would be the possible interview questions from the things that we have studied? Only thing is, right, why NumPy array is faster? That is the most important thing that can be asked here in this case. So, interview questions, I will put it like this: interview questions questions why numpy array is faster, numpy array is faster, and some of the function. If interviewer array, sorry, array I'm saying, if interviewer is really bad, then they will ask this type of function: what is use of ravel, what is ravel means flattening, right? What is ravel? Or they will ask what is expand dimension. But this is very rare that they will ask you this type of questions. How to do arithmetic operations, right? This type of questions will be very, you know, because these are practical implementation, right? They will not ask in the interview, but the theory part that we had discussed in the last, they will be asking all of these questions, right? So that would be all for this lecture. Right. Right. Guys, Piyush, that 2 point is fine. You can say that continuous memory allocation, it doesn't have any reference, right? You can size is low. You can talk about these things. Right. Now, guys, can anyone share the screen? I just want uh, someone to share the screen. So that would be all for this lecture. In the next lecture, we are going to see about, uh, indexing, slicing, broadcasting, and then we'll start with the basics of pandas. So as of now, this lecture would be this much only for this lecture. So I will just end the recording here. Right. I've ended the recording.